Okay, we're back. Today we're gonna start talking about geometry. Geometry is a very clear example of mathematics. It comes with certain assumptions. It called postulates. There are I think there are five of them. There's 2 points you can draw a line. You know, when you get 2 points, you can draw one straight line between them, and these lines can extend it infinitely both sides. With 1 point and a length, you can draw a circle. You decide 1 point, and you give it a radius essentially. Then you can draw a circle. That's postulates. But the real one is I think another one is all right angles are equal. they are they are kind of obvious, right? There's one that's essential to this, which is if you get two parallel lines, these this angle and this angle equal. Yeah. That is a postulate. That is an assumption. Okay. From that assumption, you can derive a few things. For instance, if you have a triangle, right? These three angles add up together is how much? 180. 180 degrees, right? How'd you get that?
Because, like, side I just know. You take the number of sides and you subtract by 2 and you multiply by 180.
Do that again?
So the number of sides on the object is 3.
Oh, the polygon. That's a step beyond this. In other words, if you know that this is 180 degrees, right? If you add on the side, essentially you add another triangle to it. Then you add another side means you add another triangle to it. Every time you add a triangle, you add 180 degrees to it.
Yeah.
But that's still your basis of that is why the inner angles of a triangle when you add up together is 180. Does it need proving? No. You need proving because it is, right? This is because it is. Assumption. We assume
the vertical angles and.
Do you know how to prove it? I'll prove it to you.
Okay. Sure.
Assuming this is correct. Okay, I'm going to draw a parallel line here. Okay, parallel line. Yeah, along this, right? This angle equal to this angle.
Yeah.
This angle equal to this angle.
Okay.
And this is the line. These three angles added up together is
180 degrees.
Yeah. That's how you prove it.
Okay.
Actually, if you from this you can go to that too. However, that's circular logic, you know. In other words, that postulates that assumption. You can assume that the what they call internal angles of anyway. I don't remember the way. Did I write it down? I didn't write it down. There are ways to call these angles. You need to know this because
there are vertical angles and supplementary angles.
Yeah, that's talking about this angle and this angle. They're supplementary, right? Yeah. But typically, when you say it, even if you don't know what it is, when you say it, you know. Because I never got into trouble with these things.
Name what angles?
What's these two angles? How do you call them?
How would I know?
I don't know. I'm not gonna guess about it. Uh,
I think I
there are names for
did
it.
about this.
There are other properties for this. If you extend this line, right,
Mm-hmm.
you come up with this angle, right? This angle,
Yeah.
this angle from here to here, this angle, right?
Mm-hmm.
What do you know about this angle?
That's equal to the other two angles.
These two, right? These two add up together, right? Yeah. When we're talking about geometry, we're talking about essentially two things: triangle and a circle.
Mm-hmm.
Because all the other things whenever there's a straight line, you're talking about triangles. Because any kind of a polygon that's essentially several triangles put together.
Mm-hmm.
And the circle is circle. You can't do well. Circle is a polygon with an infinite number of sides, essentially.
That thing has 0 sides. I searched it up. It says 0.
Well, I don't know about that, but anyway, you know how to calculate pi? Now we have a computer to calculate it. You know how to calculate it?
You do the side thingy that you hide.
Yeah, you get more and more sides, right?
Yeah.
Then it approaches a circle.
Yeah.
Yeah, you do essentially.
Yeah, so okay.
Yeah, that's why I'm thinking. You can say it's 0 sides. I don't know, but that's what I'm thinking. There is no right or no wrong. I assume. I don't know the reason for saying that there are 0 sides. How do you say it? Where did that come from?
There's 0 sides. I think in school you always learn there's 0 sides.
Okay.
And on Google it says 0 sides.
Do it the school way.
So
whatever.
Google's correct.
Well, I don't know about Google's already correct, but anyway, I think that's infinite number. Oh, you know what? They want to avoid the idea of infinity. Maybe the infinite number, they want to avoid that because that blows people's mind probably. What do you mean infinitely more? Infinite number of sides.
It's a really big number.
Yeah, it's a number that's bigger than any number you can come up.
Exactly.